associated probabilities. We've been given the states of the economy and the return on each state. Okay, so if the economy is on a boom, probability is 0.15, which is 15%. Invest in A, your return is 20%. Invest in B, your return is 3%. When the economy is undergoing a growth, probability is 25% or 0.25. Your return, if you invest in A, 10%. If you invest in B, your return is 35%. That's how we interpret these columns here. So we've got our first part of the question, which says calculate the expected rate of return for both A and B. So basically these are just the average returns that we're trying to get. Okay, on average, if you invest in A, what will your average return be? And if you invest in B, on average your return will be a certain number, which we're trying to tabulate here. Okay, so this is the formula for the expected return. The probability of the state of the economy multiplied by the return in that state of the economy. Okay, so that's what we're going to do here. So let me make new columns. Okay, so this is how we get our expected returns. Alright, we're going to multiply the probability with the return. So I converted these percentages, these return percentages, into decimals. Okay, if you want, you can still leave them as percentages and multiply them with the decimals. Alright, but I converted them. Okay, so for investment A, 0.15, that's the state of the economy, multiplied by 0.2, that is the return if you invest in A, you get 0.03. When there's a growth, 0.25 multiplied by 0.1, 0.025. The economy is normal, 0.2 multiplied by 0.15, 0.03. 0.3 times 0.05, we get 0.015. After we get the expected returns for each state of the economy, because these are the expected returns for each state, okay, we just need to total them up. $0.1. Okay, so the expected return for investment A is 10% or 0.1. Okay, for investment A, that is the expected return, 10%. For investment B, we're going to be multiplying the probability with the return. Okay, when the economy is booming, 0.15 multiplied by the return, which was 3%, which is 0.03, we get 0.0045, right? The probability multiplied by the return. Okay, same thing, probability multiplied by return.
So the last column, what is it? It's the expected.
Expected return for investment B.
Okay.
Okay. Let me put it like expected return B. And here expected return A. Okay, then here probability multiplied by expected return, not expected return, multiplied by the return, negative 0.015. So we just add all of them. Zero point zero 0.083, which is 8.3%. So the average return on investment A is 10%. The average return on investment B is 8.3%. Okay, so investment A looks better than investment B in terms of the average return. Right. Next, we need to calculate the risk, the standard deviation for A and B. Okay, the risk that your expected return is going to be different, okay, from what you expect. Okay, you might expect a return of 10%, but you find in actuality you get a return of 2%. Okay, so that's the risk we're talking about. So for the risks, we're going to do it each investment at a time. So we'll start with investment A. Okay, so we've already got our expected returns here. I'll just put them here. Expected return is 0.1. Okay. So this is the formula for getting the standard deviation, right? Is the summation of the probability multiplied by the return minus the expected return squared. Okay. This tabulation within the root, that is your variance. Then to get your standard deviation, you get the square root of this, and the answer you get when you do this tabulation here. Okay, so this same formula, I'm going to apply it here in the table. Okay, I'm going to open up a column for the return minus expected return. So here where we're putting return on A, we're going to just label it as R so that you know what I'm meaning in each column here. So this is just R. Okay, I don't know why it's bringing this. Yes, so this column, what it's saying is each of these returns we're going to subtract from the expected return. Okay, and after we do that, we're going to square you're going to square your answer. Okay, you're going to square whatever answers we get here. We're going to square them, and after we square them, we're going to multiply them by the probability. So probability, let me denote it as P here. Yes, so we're going to say P multiplied by we're going to multiply the probability with the expected returns. Okay, yes, so we're just following this same formula. This, after we multiply, then we'll add. So probability multiplied by return minus expected return squared. That's what we are doing here. Okay, so we begin. Okay, return minus expected return. So it says 0.2 minus 0.1, 0.1. 0.1 minus 0.1, 0. 0.15 minus 0.1, 0.05. Okay, these are basically called the deviations. All right, we're just saying how far is it deviating from the expected return. Okay, how far each return is deviating from the expected return. Okay, we get negative 0.05. So after we subtract the return from the expected return, whatever values we get, we square them. Okay, so we're going to say 0.1 squared, 0.01. 0 squared, here 0 squared is 0. 0.05 squared, 0.0025. Negative 0.05 squared, we get 0.0025. Okay, we have just squared each of our deviations. After that, we now do the final part. Right, we do the final part. We multiply the probabilities with our deviations which have been squared. So 0.15 multiplied by 0.01, 0.25 multiplied by 0, 0.2.
Sorry, how did you start multiplying there?
Have you seen the columns in yellow?
Yes.
They're the ones that multiply.
So what are we finding there? It's probability times return of
return minus. Yes, basically we're doing this. Have you seen this? Let me underline.
Yes, that one.
Yeah, this is what. Yes, we are doing this part here.
Okay.
This is what we're doing. And after we do,
when we finish the expected return, the squaring, we have squared those answers that we found on.
No, madam. Follow the process first here. We've just squared them. So after we square them, we need to multiply them with the probability.
Oh, okay. Thank you.
Okay, so the next one, probability multiplied by, I don't know, this hasn't got it. Well, these are just the individual squared deviations. That's what we can call them. So once we multiplied the probabilities with the squared deviations, okay, we now just add them up first. Okay, we get 0.00275. Okay, so after that, we need to get the square root. Okay, we need to get the square root of our answer. Okay, square root of this get 0.00524. Okay, when you get the square root of 0.00275, okay, here I just got the square root of 0.0275. The square root of this total here, the square root is this. All right. So our standard deviation 0.052 is the same as 5.2%. Okay, 5.2%. So basically what we're saying is this, to put this in layman's terms, what is standard deviation? We can think of it as, if you remember, for investment A, the expected return is 10%. So think of it as a number line here. Okay, our standard deviation is 5.2%. So 10 plus 5.2% will give us 15.2%. Plus 5.2, and 10 minus 5.2, that will give us 4.8. So this is the range at which you can expect your return to be, okay, between 4.8% to 15.2%. That's the range of the expected returns you can expect if you invest in A. Okay, it's not always that if you say your expected return is 10%, you always get 10%. No, you might get 12%. Okay, you might get 6%. Okay, you might get 13%. Okay, you might get 5%. So think of the standard deviation as like this. This is like the range where your expected return can be. Okay, any questions? Okay, so we now get the standard deviation of investment B. Okay. Remember, standard deviation is just measuring the risk. Okay, the risk that your return can be different from your expected return. Okay, that's the risk we're talking about. The return you actually get can be different from the expected return. So let me just get the returns for B. So returns for B. Alright, then we get also the expected return for B, which was 8.3%, which is 0.083. 0.083. Yes. So now we're going to repeat the process here to calculate our standard deviation. So this is the expected return for investment B. Okay, so the first thing we find the deviations, how far each of these returns is from the expected return. Okay, this first column, deviations, how far each return is from the expected return. Okay, so we're going to say 0.03 minus 0.083, we get negative 0.53. 0.35 minus 0.083, 0.267. 0.25 minus 0.083, 0.167. Negative 0.05 minus 0.083, negative 0.113. Okay, so first thing you start with, you get your deviations, where you subtract the return minus the expected return. Okay, then each of these deviations we are going to square them. Okay, we are squaring the deviations. Okay, so negative 0.053 squared, we get 0.0028. 0.267 squared, 0.071. 0.167 squared, 0.02. Negative 0.133. We get that. Okay, so we've squared our deviations. Okay, remember, we are still following this formula here. Okay, return minus expected return squared. Okay, so we've subtracted and we've squared each of our deviations. So the next part, we need to multiply by the probabilities. So everything I'm doing on that table is involved within this red circle here. Okay, so we're going to multiply the probability here, 0.15 by the squared deviation. .25 multiplied by this 0.2 multiplied by this 0.3 multiplied by this. Yes. Then after we've done everything in this red circle, we can see this sigma sign here. It means we need to add. So we add 0.00219. Okay, then the last part of this formula, we get the square root. So we need to get the square root over this value here. .17. Okay, which is basically like a standard deviation of 17.06%. Right. So a high standard deviation tells us that the returns that you might get can be very far from your expected return. Okay, if we use this analysis like for the table, we say for investment B, the expected return is 18.3% and the standard deviation is 17%. So if you say 17 plus 18.3, 17 plus 8.3. 25.2%. Okay, and then 8.3 minus 17 and negative 8.7. Okay, so you can think of this as the range of the returns that you might get. Okay, you can see there a considerable distance from the expected return, 8.3. Okay, so maybe when conditions are good, you might get a return of 20%. When conditions are bad, you might get a return of negative 1%. Okay, conditions are good, you might get a return of 18%. Okay, or you might get a return of negative 7%. So you can see these returns are somehow far from the expected return. Okay, so the key thing to remember here is this: if you want something that is stable, you're a conservative person, you don't want an investment where the returns are fluctuating, you would go for investment A because the standard deviation is low. It means the returns that you might get are not very far from the expected returns. But if you're a risk taker, you're going to go for investment B because you're speculating that you might get a return like 20% or something great, but also at the same time you might also make a big loss. Okay, so it's all about the investor. If they are asked, you, as an investor, if you are asked to decide which one would you go for, investment A or investment B, okay, first you look at the expected returns and you say, okay, investment A has got an expected return of 10%. Investment B has an expected return of 8.3%. So you would rather go with A because it's got a higher expected return. Then you now go to the standard deviations. Investment A has a standard deviation of 5.2. It means the returns you get are not going to be very far from 10%. Okay, stable investment. Investment B has got a standard deviation of 17.6, meaning the returns that you might get may be far from expected return. So again, if you're a conservative person, you still go for A. Okay, if you're a risk taker, you might still go for A or you might go for B. You're trying to make quick profits, you might want to go for B.